morning. Good morning, everyone. Welcome back. I'm Guan Yue, Manager of Strategic Initiatives at Esri Canada. I work with our executive leader team supporting our emerging businesses and our nonprofit partners. 6 years ago, on my very first day with Esri Canada, I attended the 2019 user conference here. Now, many things of that day are blurry in my head, but the stories I've heard are very much vividly alive. Today in this session, we're going to hear from 3 amazing organizations who are taking on complex challenges, from sustainable design to public safety to urban planning. We're also going to hear from some technical experts from Esri Canada who will highlight some of the latest innovation in ArcGIS. Let's start our first story from WSP Canada, a global leader in engineering, design, and innovation headquartered in Montreal. Let's check out a short video from them.
This astonishing world, with its infinite possibilities, calls to the world shapers, the impact makers, the pioneers and pathfinders, the visioneers, to see the potential everywhere. Together we can open up cities, strengthen community resilience, unleash the possibilities of a place, power the future responsibly, and fuse innovation with science. Every challenge is an invitation for us to dream big, set sights high, and blaze the trails. Together, let's unlock potential everywhere.
As a trailblazer, WSP Canada adopted this digital-first mindset and embedded GIS right in its DNA. To show us what that looks like, let's welcome Shannon, Milan, and Jennifer.
Thanks, Juan. WSP is one of Canada's leading engineer and professional service firms, tackling some of the country's most complex challenges. We have projects across the globe, and here we are showing a vast number of projects WSP has supported across North America that have been led by our Canadian teams. Now let's get into the fun stuff and begin our journey in Port Hope on Lake Ontario, east of Toronto. The Port Hope Area Initiative project represents the federal government's response to the community-requested solution for the cleanup and long-term management of historic contamination. The goal is to safely remediate and restore the land while maintaining transparency and efficiency throughout the process. Today, we will focus on the Waterworks West area. Remediation of this area took place to remove isolated pockets of contamination. For this project, we leveraged several GIS-enabled tools to streamline digital field data collection, such as Survey 123. Digital field forms used not only for sample location tracking, but for health and safety and equipment inspections, as well as automated reporting and QA/QC workflows. GPS-enabled devices were also used to achieve sub-meter accuracy. Shown here is an example of the results from a gamma scan that was conducted for this site using portable detectors. Each scanned point was geotagged and recorded in our GIS system. For this area alone, close to 15,000 data points were captured. The real-time data capture allows for immediate flagging of elevated readings, quick identification of hotspots to prioritize sampling locations, and allowing quick turnaround for lab analysis results. Here I am now showing a 3D render of the excavation data captured from the gamma scan. Drawing a profile through the excavation helps to quickly pinpoint specific gamma results for analysis. The use of interactive web applications and visualization tools is another example of allowing field crews and office staff hands-on access to real data for fast-paced decision-making. The full remediation of the Waterworks West area was completed in September of 2025. The restoration of the area included planting over 140 additional trees, installing walking trails, and accessible playground equipment. The western section of the site has been restored to its natural state, which will support potential for both wetland ecology and fisheries habitat in the Alexander Creek area. GIS is not just a support tool in this remediation, it has come to be an integral part of the success of this ongoing project in Port Hope. GIS helps us ensure safety, accountability, and real-time data-driven decision-making every step of the way. Now let's return to our project map, and we'll continue our journey with Milan as we'll head across the lakes, down the St. Lawrence, to Montreal, where we'll stop at the Jacques-Cartier Bridge.
Thank you, Shannon. The Jacques-Cartier Bridge has been in Montreal's landscape for almost 100 years. Every year, our client, JCCBI, needs to survey and maintain the 40,000 components of this bridge. It's a lot of data, as you can guess. It's a lot of data to manage with databases and spreadsheets. WSP provided the client with a management asset digital twin to provide them with a global view of the assets and support planning and decision-making. First of all 40,000 assets were modeled in 3D individually. Then they were structured and integrated into the GIS format so that each component has a unique ID and is at its proper location. Here we can see the first added value of a digital twin, which is to filter and focus on specific elements. The ability to hide or show elements to see what really we need to see. The client staff can navigate directly into the 3D scene and select elements to get their basic attributes. The general information, the location info, the specific characteristic to each type of elements. There's many in the bridge, and the most recent work that was done on that bridge. It's not just a look. Every component is there, and it can be accessed, even those pieces that are within the structure of the bridge. Once the 3D model was done and functional, we improved this tool by connecting relational tables from the client, a very important added value provided by ArcGIS. This dashboard shows the annual inspection results of all 40,000 assets. The codified colors describe the asset's condition. By hiding the assets in good condition, we can better see and understand the location of the assets that needs attention. And by selecting an item, we can see what maintenance needs to be done. Another dashboard provides the maintenance staff a tool to visualize the bridge according to the type of intervention that is done on each of those pieces. The staff can filter to focus on a section of the bridge. They can use the pie chart to select a type of maintenance. Here we select the reinforcement. As you can see, there's lots of parts that were reinforced within the bridge. We can use the 3D scene to move our point of view to go to the places that we need to see. And we can choose specific either maintenance contracts or element types to further our knowledge of those assets. Getting to the specific contract is another very important value. In conclusion, by collaborating with the client to fully understand their needs, WSP created a dynamic tool that provides centralized information. It enables collaboration between the survey team, the maintenance team, and the planning teams. In a way, we've put the entire bridge at the fingertips of its decision makers. Now that we've crossed this bridge, let's head into the woods with Jennifer and travel into northern Quebec to see how a mine is engaging with their community.
Thanks, Milan. Today I'll be sharing a story from northern Quebec, where mapping became more than a technical tool. When COVID restrictions were implemented, it still remained essential that we inform communities of projects that were in their areas, prompting us to deliver content about a complex mining project through virtual means. In collaboration with the project team and our GIS and virtual reality experts, we developed a 3D virtual meeting space. As we'll start, you notice we begin in French and then transition to English. It was critical to the client that we remain in both languages for broad accessibility to the communities that we intended to engage with. The platform ultimately facilitates meaningful connections, open dialogue, and truth building with these remote communities. The project details are presented through various story maps, each offering insight into the project's significance and its potential environmental and community impacts. Today, I'd like to focus in on the biodiversity program. This conversation starter is about the wildfires that ravaged through the study area in 2023. The project team lists their objectives, the methodology for the proposed studies, and included a schedule all the way to 2033 as to what kind of studies they were planning on doing. Next, we'll go into the interactive maps. This resource is available to every member of the community, allowing them to engage with it at their own convenience. As you see, we've started with the infrastructure layers turned on as part of the base, and I will add in the biological ones. as a way to illustrate the wealth of information that is provided to these communities, empowering individuals to seek answers to their own questions within a rich and interactive experience. Continuing our spin, we come to the library, links to PDF reports of all the published documents that have been released. I don't know about you, Shannon, but I like to have a map on one screen that I can use while reading these very lengthy reports. It actually helps to keep things in a geospatial context.
I completely agree, Jen.
This project reminds us that GIS is more than software. It is a language, one that can translate complex projects into meaningful conversations. And just like that, we've come back to the beginning. WSP has projects across the country, from coast to coast to coast. Today, we demonstrated that GIS is not just a tool. It is the foundation for trust, transformation, and transparency. In Port Hope, it enabled real-time remediation tracking and safe community restoration. In Montreal, it delivered proactive infrastructure management and digital twin capabilities. And in northern Quebec, it empowered inclusive engagement with remote communities. Thank you.
Thank you very much, Jennifer, Shannon, and Milan, for sharing with us a few examples, impressive examples of how GIS is used in many ways in WSP Canada. It's great to know that for a large organization like WSP Canada, GIS is leveraged as a catalyst, scaling innovation. Now we've looked at how GIS drives purposeful innovation. Let's turn our attention to mapping and cartography, a fundamental capability in ArcGIS that turns data into powerful and intuitive visualization. Let's welcome Allison and Maggie from Esri Canada.
Good day, everyone. Today, Maggie and I are going to explore how the power of mapping and cartography in ArcGIS Pro and in ArcGIS Online is transforming the way we visualize, analyze, and share spatial data. It's important to set yourself up for success so that you can work efficiently. In ArcGIS Pro 3.5, we have the ability to create custom pane sets. I have a custom pane set here called Cartography, which will open my geoprocessing, symbology, catalog, and contents panes. Since I'm familiar with the tool names on my top ribbon, I'm going to create some additional screen space by using the simplified ribbon option. I'll create even more screen space by minimizing the attribute table to the taskbar. This is a brand new feature. The attribute table is removed from the screen, but can still be easily accessed. This is starting to look great, but I want my symbology to look a little bit more realistic. Statistics Canada has a specific way that they symbolize these ocean drainage regions, which I have on my Statistics Canada symbology map. You can now copy and paste just the symbology properties from one layer to another using the Paste Properties options. We're working on flood zones, so let's take a closer look at some of the populated regions in New Brunswick. I'd like to see which rivers are intersecting with these populated regions. And with ArcGIS Pro 3.5, we can easily display this by using a new definition query spatial clause. We can easily display the populated regions here and then visualize the rivers that are intersecting with these populated regions. Now that I've filtered out my data, I want to set up my symbology. I currently have tapering enabled, but did you know that we have finite control of our symbology? If I click on the structure option over here, we're able to add symbol and layer effects. I currently have the tapered polygon effect and enclosing polygon effect enabled. These cartographic effects treat your lines as polygons. If I go back to my symbol section here, I can modify our parameters to make it look as though these rivers are tapering off based on the direction of flow. And with the new auto apply button enabled, I'm able to modify the symbology without selecting apply. Now that my data is set up, let's take a look at my layout here. We have a lot of great options to create beautiful layouts in ArcGIS Pro. Here's what I've created so far, but let's make it look a little better. I'll first start off by mentioning that this water texture layer is actually available to all of you in the Living Atlas. Next up, I'll mention our new scale bar type in the bottom left-hand corner here called Dual Scale Bar. This was introduced in ArcGIS Pro 3.5, and we actually have 8 default dual scale bar styles to choose from. Our legends are completely customizable. I can open up one of the properties here for my flood zones, and I can modify the patch size so that our flood zones stand out. I'm sure many of you have more than 5 panes open at a time, right? So there's a new feature where we actually have icons at the bottom of the panes here that correspond to the pane names, so that when you have so many panes open that you can't see the pane names, they're still easily recognizable. My layout is complete, but Maggie would like to work with my rivers layer in ArcGIS Online. So I'm going to share this with her to one of our shared groups. Maggie will notice that the definition query that I previously applied will actually appear in ArcGIS Online. I'll share it with my organization, I'll add it to one of our shared groups, and I'll publish the layer. And next up, Maggie's going to show you some cool new features in ArcGIS Online.
Thanks, Allison. ArcGIS Pro helps us to create beautiful maps, and when you publish the data to ArcGIS Online, we can bring those layers to life on the web. It's not just a cartographic tool, but it enables us to share clear and engaging content with a wider audience. Let's add that layer Allison just published to our map. It's easier than ever to find those features with the new ability to filter by folder and group when adding data in the map viewer. So I can add in those flood zones and also the rivers she just published. We can see the rivers are brought in with that definition query like Allison mentioned, and they also maintain that beautiful tapered symbology that she configured in ArcGIS Pro. We can achieve a similar effect with a new feature in ArcGIS Online for line features, where we can apply gradient symbology. We can select from a list of options like this light to dark blue, or we can customize it with the color picker, adding more life to our water features in our map. There are many areas in New Brunswick that experience flooding. I want to take a closer look here around the St. John River in Fredericton area, where I have the building footprints for any building that falls within that flood zone and is at risk of damage in a flood event. We can see this is a polygon feature, and we have thousands of polygons on this map, so it can be difficult to understand where the biggest threat is. With the latest release of ArcGIS Online, we can understand in just one click where those concerns are by enabling aggregation, something previously only possible with point features, now doable with line and polygons as well. Fredericton, the largest city in this area, is also where we experience most damage we can see, so we're going to take a closer look right there as well. Here in Fredericton, I have the stream gauges and a polygon of a major flood that's occurring. I want users in the community to be able to instantly see if there's a concern to them, so I'm going to make some changes. First, with my stream gauges, I want to modify the pop-up. Right now it's a field list, but text is easier to understand, so we can change that by using an arcade expression. Right now in ArcGIS Online in beta, there is an arcade assistant that can help us to create expressions using natural language prompts and AI. I'm going to ask it here to create a text prompt that displays the name of the river, the height of the water, the current status of the gauge, and the organization responsible for managing it. I've also asked it to set the text to red if a major flood is occurring in the area. We'll give it a second to generate that response for us, and then we can add it to our editor. There, in almost no time, we have a script that we can start to work with. This is a great tool to get us started, but we always want to make sure we double check what the AI produces for us and give it that GIS professional seal of approval. I know my data, for example, is case sensitive, so I'm going to make a quick change to the text so that things will run smoothly. And we have to test it out before we run. Looks like it's good to go, so we can add it to our pop-up. And in just a matter of seconds, we're able to have something that's a lot clearer for our users. The last thing I want to do before sharing this out is making it clear which neighborhoods are impacted by this flood. And I can do that with symbology. In the latest release of ArcGIS Online, animated symbology has been added for line and polygon features. So for any of my layers that fall underneath that flood, I want them to really stand out, and I'm going to add a flashing animation. It's going to take any spot there that overlaps, and instantly it's visible on the map where there is concern. I'm happy with how this looks, so I'm going to share it out to my community and colleagues. Something I would have had to do previously using an instant app, I can now do right inside the map viewer. With the new Create Custom Link tool, I can set up a viewing experience for anyone who I'd want to share this map with, including important information like legends and bookmarks. And I can add the option to open in the map viewer for any colleague that may need to make changes. Let's shorten up this URL, and I'm going to send it back over to Allison so she can see the work I've been doing and make any changes she might need.
Thanks so much, Maggie. Looks like I have a new email. This new feature makes sharing your maps easy. Today, we've shown you new features in mapping and cartography in ArcGIS Pro and in Map Viewer. You can work with the same data across ArcGIS, making it easy for you to collaborate and create beautiful and impactful maps. Thank you.
Thank you a lot, Allison and Maggie. That was great. You've shown us that how mapping and cartography are becoming more versatile and dynamic, both in the web experience and in the desktop experience. I love the tips that you've shown, including the email notification at the end. Well, now our next story is about safety in underground transit facility in Edmonton. Let's check out a short video.
Everybody has a right to feel safe in public spaces. TRAX is our transit-specific community safety team working with the transit-specific peace officers.
Yeah, he's on the ban list for assault with a weapon.
We do know, based on the data, is when the police members are in transit areas, crime goes down. When we are not there, crime goes up.
Hello, time to get up. You okay? Okay, man, so you don't have any warrants. Do you have a list of the different shelters and warming stations and drop-ins that you can go to during the day? I'll give you a card for the navigation center. You been there yet?
By being present in an area, people will see you, and the people that are there for illicit behavior or illegal behavior, they're going to leave, or we're going to immediately address it. You have the right to feel safe taking transit. It also has to be that way at midnight or at 7 in the morning. This isn't a preference, it's a right. We do not tolerate any illegal activity. By addressing those issues, you're creating a safer public space.
Feeling safe isn't a choice. It is a right, as we heard from Edmonton Police Service. However, ensuring safety in underground transit facility comes with challenges, visibility, and fast-changing situation. In partnership with DRDC and Esri Canada, Edmonton Police Service created a solution with geospatial awareness and real-time data insights. Let's hear their story from Ron and Adam.
Good morning, everyone. Edmonton Police Service provides policing to 1.2 million people within the city of Edmonton, and another 400,000 people live around the Edmonton area. Many of those people use transit to get to work, to get to downtown, and get to sporting activities in the Edmonton area. During the pandemic, like many large municipalities across North America, our downtowns were hollowed out by work-from-home mandates and other issues related to the pandemic. That created for us in the transit section of our service an issue around homelessness, drug addiction, and unfortunately also violence in our transit system. In response to that, Edmonton Police Service developed the TRAX team, which you just saw in the video, along with the provincial government providing funding for 100 additional officers. With 100 additional officers comes additional problems of logistics for us. We were not able to know at that time who was above ground or underground in our transit centers. We were not able to identify where officers were in proximity to each other when they were underground or on transit. And we weren't sure if we were deploying them as accurately as we possibly could because we lacked some of the data around that information. Next, we're going to hand it over to Adam, and he's going to take us through some of the solution.
Located in the heart of Edmonton's Arts District is Churchill Square. It's one of the city's central public gathering places. Now, throughout the year, this area will host major festivals, community events, and public gatherings. Though, as we've just heard, it continues to suffer from ongoing issues related to crime and public safety. Let's see if we can enhance our understanding of this area. Using ArcGIS reality capture, we can combine the latest in drone imagery and LiDAR scanning data to create an immersive, high-resolution 3D mesh. This mesh highlights the terrain, infrastructure, and buildings within the area. You can see the CBC building, Edmonton City Hall, as well as the beautiful Art Gallery of Alberta. Now we can further enhance our 3D mesh using ArcGIS City Engine, adding features like procedurally generated trees, as well as realistic surfaces and textures. I think it looks great. Now beneath Churchill Square is Churchill Station. It's a multi-floor light rail train station serving thousands of commuters every day. It's a vital node in the city's overall transportation network. It connects the Valley Line, Metro Line, and Capital Lines. Now, this building information model, or BIM, was created using the same data that was used to create the high-resolution mesh. It contains exterior features, including the pedestrian walkways that connect to arterial buildings, as well as interior features, things like ticketing kiosks, escalators, and elevators. Let's take a trip down to the track level. Now, every day we use GPS to help us to get where we need to go. Maybe you used it today to get here to this convention center. But when we're indoors, underground, surrounded by dense infrastructure, we can't rely on GPS signals for navigation and wayfinding. So instead, we use IPS, Indoor Positioning Systems. And we do this by deploying a network of Bluetooth beacons throughout the station. These beacons are about the size of a case of AirPods, and they just stick to the wall with adhesive tape. You can see one at the top of the ladder fixed to the wall in this photo. And once these beacons are deployed, they emit a low-energy Bluetooth signal that can be received by your mobile device or wearable, and that can be used to calculate your position indoors. In this video, we see members of the Transit Community Safety, or TRACS team, on a routine safety patrol of the station. Here they're on the track level. It's a relatively busy day. On the left-hand side, we see the ArcGIS Indoors mobile application. As the TRACS team make their way through the station, their position is calculated via their mobile device and wearables with the help of our indoor positioning system, and visualized within the ArcGIS Indoors mobile application as a dynamic moving blue dot. Now, additionally, the team can use ArcGIS Indoors Mobile to help locate station critical infrastructure, emergency equipment like fire extinguishers or portable defibrillators, and even locate each other in the event that they're separated. As part of this proof of concept, we also looked at integrating with officer body-worn cameras, which are becoming more prevalent around police forces throughout Canada and are vital for transparency and safety, not only for our officers, but for members of the public as well. Okay, So far, we've looked at indoors and IPS from the perspective of our officers on the ground. I'd like to switch gears now and look at it from the perspective of an operator in a command center. Again, we find our tracks team on patrol of the station. Here they're still underground, one level up from track level on the concourse level. And on the left-hand side, an application that was developed using the Maps SDK for JavaScript. Now, this application allows the operator to view in near real time the location of these officers underground, capability that just would not be possible without indoors and IPS. Additionally, we added this nice heat map visualization. This helps us indicate the overall accuracy of the system as the officers make their way through, and helps us to monitor the overall health of our IPS deployment. Our operator can also use ArcGIS dashboards to, again, see the locations of our officers indoors, but also integrate with additional sources of data. So as part of this project, we deployed additional IoT sensors throughout the station to gather telemetry, including temperature and air quality, not only important for our officers, but for members of the public as well. We also examined footfall data, so the number of people entering and exiting the station throughout the day, and that gives us an idea of overall station capacity at any given time, which can be important for measuring officer response times. Finally, we integrated with the system, with the station's security camera system, providing an overall enhanced picture for situational awareness. Okay. Finally, I'd like to share with you an application that was developed using the Maps SDK for Unreal Engine. This application combines data from both the building information model and 3D mesh to create a truly immersive and unique experience. Let's start with a bird's eye view of Churchill Square and think about how an application like this could be used for pre-event planning for some of those major festivals I talked to about earlier, to help give someone an idea of the layout of the square, and if there are any locations which might be required to address security needs. Jumping into a first-person perspective, we can think about officer onboarding, helping to have an officer understand the layout of the station, the location of emergency features before they have to go on that first patrol. And finally, officer training, having the ability to replay an officer's position as they respond to an incident and then learning from that experience. And I think we're just scratching the surface of what's possible when we use ArcGIS indoors and IPS to help improve situational awareness in environments like Churchill Station.
Couldn't agree more. For the Edmonton Police Service, the outcomes we've achieved in this is better response times underground, better officer safety by knowing where exactly they are throughout the transit systems. Virtual staging, as we referenced, can be done if we have a major incident in the underground or in our current transit environment, as well as the ability to share this type of data with other emergency services down the line. What does the future hold for this? In Edmonton, we've already started 3D mapping the remainder of our pedways and our underground walkways with our GIS team. We're looking at the West Edmonton Mall. As we all well know, that's a large center in the city of Edmonton where we have difficulty obtaining officer location information. And we're hopeful that we can get it into places like Rogers Place in downtown Edmonton for when Toronto Maple Leafs come to defeat the Edmonton Oilers next spring. So thank you very much.
Thank you, Ron and Adam, for that powerful look of how data and spatial awareness is transforming public safety and building more trust in our cities. Since we're talking about the importance of data, let's turn our attention to the vital capability of data editing and data management in ArcGIS. Let's welcome Justin and Sue from Esri Canada.
Thanks, Juan. Anybody here who's ever done any type of field editing or data editing within ArcGIS Pro knows how significant it is to have reliable data for your users to use. Today, I will be using some of ArcGIS Pro's newest data editing functionality to help simplify some of these workflows for us. Specifically looking at Hamilton, Ontario, there's approximately 14,000 fire hydrants throughout the city. Now, if you ask me, by looking at this data, that's a lot of fire hydrants. So let's start by narrowing down this data. By using a spatial definition query, we can simply apply a spatial clause to our data to simply narrow down the area of interest that we would like to analyze for today. By doing this on all of our layers, this makes our data much more manageable to handle and much easier to do our edits with. By simply applying that filter, we could see that our data set is much smaller now, much easier to work with, which is amazing. So let's now start looking at some edits that can be made. By looking at an area of interest for today, there's a couple points here that we're going to be editing. Let's start by thinking about how we can make our edits easy to read. For this instance, I've applied an attribute rule on the same layer that I applied my filter on, our fire hydrants layer. For this attribute rule, I utilize one of our new attribute rule templates, specifically the Generate ID template. This template allows me to select a field. In our case, this is our hydrant value, and it allows me to simply follow the naming convention that we have within our attribute table by using this field, which is amazing. Let's see how this looks in the works. We'll go ahead and start by turning on our labels here. Here, we're only going to see the labels for our pre-existing features pop up. And we'll go ahead and we'll turn on our distance and directions measurement layer here. Perfect. Okay, so our labels didn't show up in this situation, but we're going to show you guys how this looks. There we go. When we go ahead and we create some new labels here, we got them to generate now, which is good. In this instance, we could see here we've got a couple fire hydrants in our area of interest, which is amazing, and we're going to make some edits on these. So on fire hydrant on the right-hand side, hydrant 1809, this fire hydrant specifically is being decommissioned. So it's our job where our measurements are that were calculated using the distance and direction measurement tool in ArcGIS Pro to simply add in a new fire hydrant at this location for us. So let's go ahead and start doing that. Here I'm going to zoom into our point here, and since our calculations have been made approximately 90 meters apart from the other fire hydrant in the area, let's simply go ahead and add in a point. So we'll create a new fire hydrant layer, and since I have snapping turned on, this is very easy to do. And automatically, we'll see there, a new label has been generated following the schema that I've set up within our attribute rules. So the numbers are going to keep adding on sequentially as we go on and add in new features. Now, since the fire hydrant nearby is only being decommissioned, we in fact want to transfer over the attributes from our data, including the attributes and the naming from the decommissioned fire hydrant to this new fire hydrant that I've now created. The only thing that's changing here realistically is the location of our data. So let's zoom in and do that. Using the new Transfer Attributes tool, we can simply select the tool in our editing menu, select our old point or our decommissioned fire hydrant that we would like to start our edits with, and simply click our new point and transfer over the attributes. And there we go. Now all of our attributes for this corresponding fire hydrant have been transferred over to our new feature. So that's great. We can go ahead and now finish our edit with this specific layer. So let's turn on our distance and directions again, and now I'll simply add in a feature to connect our fire hydrant to our water main to wrap up this edit. Simply drawing a line or measurement line here, and double-clicking to finish our edit, we could see that our new feature has now been created with our measurements and is ready to be used. Now we're going to wrap things up and kind of delete our old feature here since we don't need it anymore, the one for the decommissioned fire hydrant. And we can simply just delete these features. Okay, so now that we've done that edit on our data, we've transferred over the attributes using that very powerful tool. Let's zoom out and let's see if there's any more edits that need to be made within the area. Specifically within this area of analysis, we've got a couple more edits to be made actually, and we're going to specifically look at one more for today. But by utilizing one of our new menus available within ArcGIS Pro, specifically the vertices and nodes menu, we can see how editing your data is now simplified. Seeing things by having this menu turned on, you can see things like vertices, dangles, and nodes within your data. And that's incredible because they're all represented by different logos, and this will visually make your editing capabilities much easier within the software. So let's close out of this menu and turn this on. Here we could see automatically hydrant 7077 has an edit that needs to be done. And we could see that because it's represented by the dangle logo, a red square. And that means that our feature is incomplete. So let's simply finish this feature, and we'll use our extend tools to do this. By selecting our feature at hand, and by going into our editing menu, we can simply select our extend tools and extend our node to the water main line. Now, one thing to note here, since I have snapping turned on, I can click anywhere along this water main line, and it's automatically going to do that edit for me and continue the feature in the direction that it was originally created in. That's a great feature to have, if you ask me. Now that our edits are complete, I'm going to make sure that my layer is saved and published to ArcGIS Online, where Sue will walk us through some of the additional capabilities that we can look at in terms of applications when it comes to data editing.
Thank you, Justin. So I'm going to take us into ArcGIS Online, where I'm going to check some of that field data before we go out for verification using a new app for ArcGIS Online called Web Editor. Now, you may notice Web Editor looks similar to the map viewer. However, the tools are very streamlined, so it's easy to use if you're a non-GIS user, but we do provide some more advanced capabilities if you are an experienced GIS user. I've already opened the map I want to work with, and I'm just going to check some areas, and I noticed that in this area, that the water main connection to this hydrant is missing. So to add that, some of the tools in Web Editor allow me to place a grid, which I can align and lock to my existing features. I can also turn on snapping, and I can snap to existing layers as well as to the grid. To create a new feature in Web Editor, I have a different set of tools depending on the type of feature I'm creating. So in this case, I'm working with a line. I'm going to start with that straight line. And if you notice the snapping is coming in, I'm going to snap right to the end of that water main. Now, Web Editor also gives you some keyboard shortcuts, which allow you to go in and add, say, a constraint. For example, I'm going to add 10 meters for this first part. I might have gotten that from an as-built. So even if I snap to the grid, the first vertex is added at 10 meters. And I could do deflection and other things like direction. I'm simply going to snap to the end of that hydrant lateral. And the form for my feature pops up, and I have some default sets, so I'm just going to create that. Now, Web Editor also provides capability to do batch edits. So for that, I'm going to work with a different set of features. The features on the map that you see are ArcGIS Field Map Task, a new layer type, which will work within the field in a moment. But because they're just a feature layer, I can edit them in another app, such as Web Editor. So to use the batch editing, first I'm going to make sure that I only have my hydrant assignments on. So these are going to tell our field workers where to go and what to do. I'll select a small subset and then bring up the batch editing. Now, field map tasks are created and configured in Designer, but I can work with that form in Web Editor. So what I'm going to do is I'm going to assign this work to someone I know who is working in the area and make the due date to today. And Web Editor also allows you to save your map and your tools to an app using our new Web Editor Instant App templates. So now I'm going to switch over to the field, and for this, we're going to look at my iPad. This is where we're going to see tasks light up in Field Maps mobile app. So I'm going to open up that map, and we can see the to-do list now. So this is my work, and I have different types of filters I can, again, figure in Field Maps Designer. In this case, these are high priority that are assigned to me, but I could also view unassigned work, that if I can pick up something I see that is going on near me. I can also change how I sort those tasks, either by distance, type, or priority, but let's go back to those ones that are assigned to me. I'm going to pick the one that is closest to my location. Now, I could get directions, or I could just get a compass distance and bearing if I'm nearby. I'm going to start this, and when I start the task, it alerts anyone back in the office that I have started that work. I have different actions configured for that task. What I notice is this hydrant, oops, let's go back to that one. Let me cancel out of adding. There we go. This hydrant is actually in violation. So I'm just going to change that and update that point. And then I can actually go and get information about the hydrant feature itself that I'm going to be inspecting. And I can now see all the related records for hydrant inspections. But I'm going to actually go in and add a new one. And I'm going to say that this hydrant is in very poor condition, it's not operable, and it actually needs some maintenance. So I will submit that new inspection. I've also noticed that the nearby hydrant also is in violation. So to update that, I'm going to use the Edit Multiple capabilities that is available now in Field Maps. I'm going to select these two hydrants. And then I'm going to see the form, and I can see there sometimes are multiple values, but I'm just going to update the inspection date to today. And finally, I'm going to add a task, because I can do that now in the field. So I'm going to assign this to myself, because I'm going to complete this inspection. So another violation of high priority, assign it to myself. I could also leave it unassigned for someone to pick it up. And now what I'm going to do is I'm going to finish that first assignment. And note that tasks work while disconnected in an offline environment as well as connected, as you've seen today. And they also replace the ArcGIS Workforce app for a more streamlined workflow. So we hope that you've seen some useful edits today that you can do with the new tools in ArcGIS Desktop, online, and mobile, and that we have inspired you to try using field map tasks to streamline your mobile operations. Thank you.
Thank you, Sue and Justin. As you mentioned, Sue, what struck me the most is the seamless data flow across the entire ArcGIS, from desktop to ArcGIS Online to mobile applications. The distributed yet connected nature of ArcGIS is essential to weave together a single source of truth while keeping the data up to date and accurate. And speaking about a single source of truth, our next story is going to show us what that looks like and how impactful it is. Let's check out a video from the town of Oakville, Ontario.
I just really got tired of digging into the same data over and over again.
It could have taken us a month or two to get back to them. At that point, the moment's gone.
When people tell me that something can't be done, then I'm the type of person who will look into something and get it done.
It's a one-stop shop where you can find data and information.
And so I was able to pull out the phone, pull up a website and say, here is the information right here.
We wouldn't have been able to advocate for ourselves to get this $7 million funding if it wasn't for the Data Hub work.
The moment felt like the hard work was worth it, and that there was going to be a meaningful impact that would be really visible to the community.
Our decisions are much more data-based, so we can make very good, accurate decisions in terms of moving forward.
It really helps show people the power of data and using data for proper decision making, and how the data can have a huge impact in your community.
If every municipality could start to do this, right? And then we can maybe start to get a standardized ways of reporting out. And imagine a province-wide data exchange where we can all share data and learn from each other as we plan our communities.
A one-stop shop of data and insights for decision making. That's powerful. It takes a whole team of dedicated people who dare to dream and never give up to bring that powerful vision to reality. Let's hear their story. Let's welcome Frank and Jeff.
Thank you, Guan. As a planner, it's often my job to orient people to the location I'm talking about. So if you're not familiar with where Oakville is, let me help you out. We're located halfway between Toronto and Hamilton, on the shores of Lake Ontario, sandwiched in between Mississauga and Burlington. And standard convention puts north at the top of a map. But for a lot of us in Oakville, we refer to north as the direction away from the lake. So that's why you'll often see maps of Oakville oriented like this, about 52 degrees off of north. This is our urban structure. It's an important part of Oakville's official plan and essentially guides how we plan for tomorrow in Oakville. Generally speaking, the green areas are our natural heritage areas, our parks and open space system. The blue is the employment. Yellow is our residential neighborhoods. And the purple areas are our growth nodes and corridors. These are intended to be high-density, mixed-use areas supported by higher-order transit, like the existing Lakeshore West GO line, as well as future bus rapid transit on Dundas and Trafalgar in Oakville. One of the areas that we've been focusing on recently is Midtown Oakville. And I'm going to use Midtown to show how we've been using GIS and Esri tools to help us develop policies for these areas, as well as assist in our development review. So let's take a closer look at Midtown. And our task was to update our policies so that they would achieve a minimum of 200 people and jobs per hectare, but then also determine an appropriate maximum. It's important to set a maximum because it helps with planning the infrastructure that's needed to accommodate that growth. So the animation I'm about to walk you through is what we used to help explain how we did that to both town council and the general public. The first thing we needed to do is figure out where could development and redevelopment happen within Midtown. So we start with the existing parcel fabric. And then we remove places that can't be developed, like our existing rights-of-way, our existing parks and open space, the railway corridor, as well as other public utilities. And then we integrate the future road network that we have proposed for Midtown. And last, we add a future conceptual parks and open space system to that mapping. And what you're left with are these blue blocks, these blue areas. And we were able to take these blue blocks and bring them into ArcGIS City Engine. And then using CGA rules that we're developing in-house, we were able to lay out building footprints across the area. And then generate 3D massings for various scenarios. This one happens to be the minimum amount of development that we would need to meet our 200 people and jobs per hectare requirement. As the rules build out the model, gross floor areas are reported out for each of the stories as they're built. And then using a base set of assumptions, we're able to get the model to estimate the number of units that would be created, the amount of office and retail space that would be generated, and then calculate an estimate for the residents and jobs that would be created by these scenarios. We then took this model and were able to create a dashboard. And as you can see here, this scenario produces about 205 residents and jobs per gross hectare, which is about 21,000 residents and jobs. The white numbers you see here represent the heights of the buildings in stories, which was really important for our town council and the public specifically. And in this scenario, the tallest building ends up being 25 stories, but generally it's about a 9 or 10-story building. You can also click in on various blocks with pop-ups that have more of the detailed indicators that were produced by the model. And you can also select more than one block to get that, and you'll see the numbers over here on the left-hand side update. And this is really useful if you have a proposal that may encompass a couple of these blocks. You can then compare what's being proposed to the model itself. We also did the same for the maximum scenario and brought this into a dashboard as well. One of the things that we really needed to emphasize with council and the public was that this model was not meant to represent what will exactly get built at the end of the day. It was more of a representation to allow us to model out and test the policies to see what they would result in. So you can see here the overall density ended up being about 485 in this theoretical max build-out scenario for about 50,000 residents and jobs combined. And you can quickly flip back and forth to compare. The City Engine model was also very useful, we discovered, for a number of other things during our public engagement. This here is a screenshot of a video that we created and posted on the town's website to help explain some of the concepts within our proposed policies a little bit better. And the model really made creating the visuals quite simple and straightforward for this purpose. The model also helped us create higher quality renderings that I worked with our urban design team on to create for one of our public open houses. These are 2 panels from one of those open houses to display that work. And you may notice that there are QR codes on one of the panels. And this allowed attendees at the public open house to pull out their smartphones, click on the QR code, and then immerse themselves in a number of 360-degree photospheres. Our hope was that this would help people better be able to visualize what the implications of our policies could be, and then give them the time to look around at their own pace to see what these policies might result in. We also discovered that this modeling helps us with site-specific proposals that we might receive. We may get a site plan concept submitted, or in this case, a landscape plan, and we'd like to see a 3D visualization of what this concept might be. At times, the applicants do provide 3D models, such as the SketchUp model that we're able to bring in. But I've also found that sometimes the models submitted by applicants are extremely detailed and can be quite cumbersome bringing in when all we're looking for is a fairly straightforward massing. So what we were able to do is we can just sketch in GIS, using the 2D plans as a guide, the floor plates for the buildings, apply our city engine rules to them, and create fairly quickly some 3D massings that really help us look at the scale that we might get, and it may be a little bit more detailed, which might be better than just a simple block massing. And like the city engine model, we're also able to estimate what the units might be or how many people and jobs might be produced by this application. And now I'll let Frank show you a little bit of our planning and data hub.
Thanks, Jeff. I'm always blown away at all the stuff that you're doing with City Engine within the town. So Jeff and I are always getting asked by our CAO, mayor's office, people in the general public of where is the growth happening in Oakville? How many proposed developments do we have? How many approved units do we have? How many housing starts do we currently have? So at the direction of our CAO, we were asked to develop our Town of Oakville Planning Hub. And working with many departments, we came across that we decided to build out some dashboards for development applications, building permits, committee of adjustments, various community profiles, as well as best planning estimates. If we jump into the development applications, that brings us into a site-specific page directly for this. Inside of it, we're showing information that is directly connected into our Amanda system. If we pop it open into a bit larger site, we can see right here that we currently have about 226 applications active inside of the town of Oakville for about 40,000 proposed units. Also, the information that you see on the side here, this is all live directly from our Amanda system, which is what we use for permitting. So if a permit gets updated today, the following day, the information on this site is automatically updated. Also, if we were to scroll down, we can go to one of these sites, and we'll click on, we'll go right here. And you can see right here that we have a site for 60 stacked townhouses. Again, we can click on information to get more information on it. But then we can also start seeing other pieces such as the total number of proposed units that we have, the total, and then broken down by unit type. One of the big things that we wanted to do is make sure that we put definitions inside of our sites. We know that within planning, they have a lot of their own little lingo that they like to use. So what does it mean when we start talking about, what does the OPA mean? What does certain statuses mean? And we just lost it, but that's okay. So what do we mean by clearing conditions? You can see that we put clear definitions directly inside of it. The other piece that we also did, if we scroll down, we can give it a spot where you can directly download the data. At the same time, we also create a site directly for building permits. Again, this data is from our Amanda system, and it gets updated daily. And these are some of our most used sites that we have at the town. Up in North Oakville, inside of here, this is where the bulk of our growth is actually happening. And in South Oakville, while it looks like there's a lot of building permits, this is a lot of tear down rebuilds of houses. Again, we can then click around and get whatever information we'd like and have the same definitions and breakdowns. Lastly, the last page that we created is for best planning estimates. And this is a series of sites, this is a site that was developed with planning estimates from the area municipalities. So currently in 2021, we had about 220,000 people living in the town of Oakville. But as we progress up to 2051, it's supposed to go up to about 440,000. But with the influx of new people is going to come more units and more employment growth. So we can see by 2051, we're supposed to go up to about 170,000 units within inside the town of Oakville, starting currently at around 73,000 units. Now, one of the pieces that we always are getting asked is, what is going to be the growth of certain areas within inside the town? So if we were to scroll down to the midtown that Jeff was referring to, that population is supposed to go up to about 32,000 by 2051. And with the new population, will become employment of about 17,000 people. And with that, we have people and jobs forecasting. So these tools have been instrumental for the town of Oakville, and it's helping us to generate numbers, saving time for staff members, as well as being used for helping us to get funding from various different departments and agencies. And this is some of the tools that the town of Oakville is using for planning for tomorrow. Go on.
Thank you very much, Frank and Jeff. That was incredible. And your story shows us transparent, collaborative, and evidence-based urban planning is no longer the future. It is here today. And GIS is not just the tool you use, but how you work. That was great. Now for the last showcase of this morning, let's move on to spatial analysis. If mapping and data editing are foundation of GIS, spatial analysis leads us to where we want to be, the insights. To show us some of the latest features in spatial analysis, let's welcome Mary Jane.
Every day, children walk or bike to school. By analyzing traffic collision near elementary schools, we can help city policy planners, school boards, prioritize safety improvements where they're needed the most. In this dashboard, you can see elementary schools ranked by decreasing safety score. You can also see important statistics on collisions just to the right. To build this kind of dashboard, we'll head over to ArcGIS Online Map Viewer, where I'll navigate to Ottawa, where thanks to Ottawa's Open Data Hub, I was able to get a copy of elementary school locations as well as traffic collision data. I've symbolized the traffic collisions by maximum injury, and we can see that just right up here to the north, we have unclassified data. To rectify that, I'll head over to ArcGIS for Excel. I can log in directly into my organization and add in a feature layer. I'll navigate to that same area and select my data. While that gets updated, I want to mention a powerful update. Now you can edit line and polygon geometries, not just points, as well as attributes, as you've seen. I'll head back over to my map, where you can see that the data has already been updated. And now let's dive deeper into my analysis. I've created a model builder directly in Map Viewer. I'm using the new Filter by Collisions attribute tool to filter out data that's most important in this scenario, such as cyclist collisions or pedestrian collisions. I don't want to have an output of this data since it's just for calculations, so I'll choose to create intermediate data. Then I calculated a composite index where I calculate the number of pedestrians, number of cyclists, and numbers of injuries and number of fatalities, because these are the things that are most important on that we need to focus. Finally, I've summarized that score into a 1 kilometer walking area around each elementary school. And I'm using the new variables to identify the cutoff of 1 kilometer. One thing I want to mention about Model Builder is it's now available for Professional and Professional Plus users, and it really helps to create multi-step analyses directly in the browser, no coding required. You'll notice here that I can disconnect and still query my model. You no longer have to have an active session and consume credits. Let's take a look at the output, the cyclist and pedestrian traffic collision layer that we've created, and I'll navigate back to the sector we were in earlier. Here's a noteworthy example. This is an accident that happened just around 5 p.m., right around when school lets out, involving a vehicle and a cyclist. It happened during daylight, clear roads. Now, this type of layer is interesting for querying specific data. And I've created this layer by adding in an attribute called collision type and using arcade to focus in on the cyclist and pedestrian fatalities and injuries. Then I used the animated symbology on just the fatalities. So it really grabs your attention. So what do I do now that if I want a little bit more of trends, if I want to see trends, something out of just the point data? I can create an H3 hexagonal bin. This is what I've done here. These are new and can be created with the Generate Tessellation tool. We'll head over to my maps history to look at that. I created the Generate Tessellation tool with the H3 hexagonal bins, and then I summarized within them that index score. And using my maps history, I can bring those back in. I now have important information just in the pop-up right here. All these layers are very important to give us a nice understanding of what's happening around each elementary school and focus in on that, on every incident or accident that could potentially be horrific, right, for elementary school students. What if I want to overlay that data now and get to a prioritization? That's where the relationship map comes in. I can use two variables, for example, count of students walking or biking, and the risk score that I created, and pick the relationship style. Then I can focus in on the grid size, pick a sampling method, and then also fix my legends here, my labels. I can bring this all back into my dashboard. And now I'm able to query which areas need the most improvements, crossing guards, safety, calming measures. And I can hand this off to school boards, policy planners, anyone who has children's safety at heart. Thank you.
Thank you very much, Mary Jane. I like that you showed ArcGIS for Excel can directly edit feature service from ArcGIS Online, and your entire spatial analysis workflow was run on the browser. As we've seen from this session in the morning, that organizations are using GIS to push the boundaries of what's possible, connecting people, data, and decisions. And through the demos, you've seen the evolving capability of ArcGIS are making those stories possible. Let's give another round of applause to all of our presenters in this session for sharing their inspiring examples That concludes our morning session. I hope you have a good break and keep telling your stories. Thank you.